Hi and welcome to another Carpenter Tutoring tutorial. I'm Amy and today we are going to walk through some examples of solving one-step equations for different variables. Now what a one-step equation means is there's only one relationship with the variable that we have to break before we get that variable on its own. Because it just has one relationship, these are often considered the simplest equations to solve, but that doesn't always mean that they're easy. As we look at the last one, for example, it might stump you for a minute, so it's a good idea to look over some of these together and get some experience under your belt before you tackle them alone. Let's go ahead and start with our first problem, which is x minus 3 equals negative 8. Whenever I'm starting solving an equation for a variable, the first thing I have to do is find that variable. I see that I'm working here with x, so my job is to get x on its own. The way that I do that is break any relationships that it has with numbers on the same side of the equal sign. The only connection that I see is what it has with the 3. It has 3 subtracted from it. This means that I'm going to have to break that subtraction using addition. Why do I use addition? Because we always break relationships with their opposite operations. So I can get rid of this minus 3 by adding 3 to both sides. Now you might be wondering, why am I adding 3 to both sides of the equation? Why not just the left side? Equal signs are like scales. We have to keep balance between both sides of that equal sign. So whatever I do on one side, I have to do the exact same thing on the other, or I'll upset the balance between these values. On the left side, subtracting 3 and then adding 3 cancel each other out. So these two operations basically create an addition of 0, which doesn't change the value at all. So the only thing remaining on that left side is x. On the right side, negative 8 plus 3 takes me to negative 5. Now that I've gotten to a place where I have my variable on one side of the equal sign and a single numerical term on the right side of the equal sign, I know that I have my answer. I've solved x and found that x represents the value negative 5. To double check that this is correct, I should go back to the original equation, plug in negative 5 where x had been, and make sure that everything comes out correctly. I'll replace x with negative 5, and then write everything else just the same. So negative 5 minus 3 equals negative 8. Well, negative 5 minus 3 would be negative 8. And negative 8 does in fact equal negative 8, so that tells me that negative 5 is the correct value for x. We've solved for x and we checked our work to make sure that we didn't make any mistakes. Let's take a look at the next problem. I have negative 18 equals w plus 6. In this problem, our variable is on the right-hand side. That's okay. It doesn't matter what side of the equation the variable is on. All that matters is that we want to get that variable alone, regardless of which side it's on. Again, I know that I'll be working on getting w on its own. The only relationship that I see between w and a number on the same side of the equal sign is the addition with 6. Because 6 is being added, I'll have to use its opposite operation, subtraction, to undo or break that relationship. So I'll subtract by 6. Because I'm doing that on one side of the equal sign, I also have to be sure to do it on the other. So I'm subtracting 6 from both sides. 6 and minus 6 will cancel each other out, so these go away. That means we only have w now on the right-hand side. On the left-hand side, we'll have negative 18 minus 6, which takes us to negative 24. Again, I've gotten to a point where I have a numerical value on one side of the equal sign and my variable on the other side. This means I have now solved for that variable. I know that w represents the value negative 24. In this case, our variable is on the right side of the equal sign, and again, that's okay. All that matters is that we have a number on one side and our variable on the other. Let's go ahead and do our check and make sure that the value of negative 24 actually makes our statement true. So we have negative 18 equals, instead of w, I'll write negative 24 plus 6. I don't have anything to do on the left-hand side, so I'll still just write negative 18 equals. On the right-hand side, I can add negative 24 and 6. Well, negative 24 plus 6 is negative 18, and negative 18 is equal to negative 18, so we know that we did our work correctly. Finally, I have 3/4 m equals 9. My goal will be to get m on its own by breaking the multiplication relationship between it and 3/4. Now here's where we get some wiggle room. I know that the opposite operation for multiplication is division. So one way that I could do this is dividing both sides of the equation by 3/4. But dividing by a fraction isn't something that I love to do. A way that I can change this problem into a nicer operation, something that I'm more comfortable with, is thinking about keep, change, flip. Or in other words, recognizing that multiplying by the reciprocal is the same thing as dividing by a fraction. Now, if you're not sure what those words or terms mean, we have another video on that, so I suggest you go check it out because it gives you more options for solving these kinds of problems. If you like dividing by fractions, awesome. Go for it. But if you're like me and prefer doing the multiplication, we can take a look at how that will work. So instead of dividing by 3/4, I'm going to choose to multiply by the reciprocal, which is flip-flopping the numerator and the denominator. So instead of 3/4, I'll have 4/3. Since I'm multiplying by 4/3 on one side of the equal sign, I have to make sure to do that on the other side as well. The multiplication between these two fractions will produce a product of 1, and 1 times m really just leaves us with m, so the only thing we have left on the left-hand side is m. On the right-hand side, I'll have 9 times 4/3, which becomes 36/3. And I see that I can simplify that further because 36 divided by 3 is 12, so I know m equals 12. Again, we can take that value we found for m and plug it back into our original equation to make sure that the value holds true. So we have 3/4 times 12, again replacing m with the 12 that we found, equals 9. 3 times 12 is 36/4 equals 9, and 36 divided by 4 is 9. And 9 does in fact equal 9. Those are the same value. So again, we know that we've done our work correctly and found that m equals 12. I hope it's been helpful to walk through a couple examples of one-step variable equations together. If you have any questions or other topics that you'd like to see discussed, please let me know in the comments. If you like our content, I hope you'll consider liking this video and subscribing to our channel. Thank you so much for spending part of your day with me, and I'll catch you next time.